if your group had 1 point that they could estimate what they thought mu was, you would have used your group what? X bar. So we are using a single statistic based on sample data to estimate a population parameter. And really, I shouldn't need to write the word population parameter because parameter is only about population, but. So in our example, we were trying to estimate what parameter? Symbol. Mu. What did we use as our point estimate? X bar. For our class's case, what do you think is the other parameter we're most of the time going to try to be estimating? We deal with standard deviation just like we did before, and we could estimate if we don't know that much this class. Proportion, and what's our proportion parameter? The parameter is what for proportion? P. So mostly we would use X bar or P hat. Again, I could use S to estimate sigma. I could use all kinds of different things that are statistics and parameters. But just like in chapter 7, we usually dealt with these two. That's most of the case that we're using. All right, margin of error. So I have not brought that up yet. But what on here do you think is talking about a margin of error? The what? The width, right? So which color is best describing the width? The blue. So your margin of error, this is kind of a very vague written here, shows how accurate we believe our estimate is. In our example, this was the horizontal. My color was blue. If you wrote it a different color, write that there.
Can you go back to the video?
Yeah, it was just the one connecting them. Gotcha. We're going to be able to find margin of error different ways, but let's actually think about an equation for this section right here. It's like from here to here. How did I figure out how long that was? For any of my groups, how did I figure this out for the 95%?
The mean is having the same shape.
So just this distance, not talking about mean, not location, just this distance. Okay, I did 2 times, and what did we use our symbol for standard deviation? All right, what was our equation for sigma of X bar? Sigma over square root n. But what does this mean? How many did we do it here? So it's 2 what from what? From the, Okay, so what definition do we have that is number of standard deviations from the mean? That is our z-score. So in our example, the way we found margin of error, we took our z-score, and yes, I'm putting z with a star right now, that doesn't matter, times our standard deviation, which was sigma over square root m. And that's just one example, because if we're dealing with proportions, obviously that's going to change. There are other times it's going to change, but for right now, that's at least relatable. Say it again. Oh, margin of error. All right, confidence level is the success rate of the method used to construct the interval. I didn't write here what color my point estimate was. Mine was orange. So your point estimate was whatever color your dot was in the middle. I would write that. And we wrote this on the front, so you don't have to write this. Your confidence level goes up when your width goes up. You are going to, and I can guarantee this, and I guarantee you'll see it on the AP exam somewhere, be asked something about a confidence level, but also confidence interval, and they interpret differently. So these are very important from the beginning. So that's going to be a number there. It's what percent. So let's go back to this example. That 68% is all I am interpreting here. That 68% means this gray line that I actually don't know where it exists would do what 68% of the time. Each one of, how many of these would I have, the blue, green, orange, how many of those would I have to be able to get to 68%? Theoretically, what? Why did I stop at 6? We weren't sitting here all day. How many of them are there?
5.
How many actual of these could I make? A whole bunch, right? So theoretically, this 68 applies to this line if I have how many samples? All of them. So it's 68% of all possible samples. We've dealt with this portion of what's really important before in 2 different categories. It's all possible samples of what? It's not just in general all samples I can make, but it's all possible samples of that specific size. of size n, written in context. So this many percent of all possible samples of n will actually result in an interval that captures and for right now I'm going to write it as mu or p. That is not a mu divided by p. That is I either put mu there or I put p there. Because those are the two we're going to deal with for this class, which would be the true mean or proportion written out in context.
I'm doing the thing where I usually write in different color.
My parentheses stuff is that's different color stuff, yeah. Yeah, I should have done that. So the stuff where I'm choosing to fill in is the parentheses stuff. The big difference here that people get mixed up is that's not saying if I go walk in that pitch black room and throw one hula hoop, that my one hula hoop is 68% likely to capture the true mean. That is not at all what it is saying. It is saying if I walk in that room and throw a whole bunch of hula hoops, 68% of the hula hoops would capture it. So that 68% does not apply to that one individual hula hoop. It applies to how many hula hoops out of the total would actually do it. And that's where people get mixed up a lot. Am I still writing that one? Alright, so confidence interval instead is that lower upper. So it is used to estimate, this is like my green dots. Used to estimate the unknown parameter and it's going to have a lower number and an upper number. So let's think through how I know how I can get my green dots in any scenario. So what's the first thing I need to know to be able to get my green dot? My orange dot. What is my orange dot in general? Point estimate. In our case, it was X bar, but it could have been P hat. So I start with my point estimate. And then where do I go from there? How do I know how to get to this one for my point estimate? And what is this? What is this called?
Margin of error.
Margin of error. So I am taking my point estimate. If I go to the left, I'm doing what? If I go to the right, so you're both adding and subtracting your margin of error. Which we can break down if we wanted to. What is your margin? How do you find your margin of error? Your z-score times.
Sigma over square root.
Okay, so let's be very generic here. I'm going to tell you that the Z star is called a critical value. I'm going to write Z star right now. What, in general, this is my equation for what? My standard deviation of x bar. We're going to just write that generically as standard deviation of statistic, which sounds weird. Because it's sigma of x bar or sigma of p hat. I don't need you to be perfect with me writing these out, but you shouldn't be lost on where I'm getting them from. Okay, so we have an interpret for confidence level, which is if I throw hula hoops all day, the percent of the hula hoops that would actually do what I wanted it to, that I'll never actually know the answer to. Confidence interval is another interpret, which is the one that you do more often. We are, I am, they are, I don't care about that part. Blank percent confident. What number do you think is going to go here? Whatever my what is. Whatever my confidence level is. We are blank percent confident that, well, what are we trying to throw the hula hoop at? Which, for our case, is we're trying to estimate a what or what? Typically. What did I say for the most part we're going to be estimating? We're going to use x bar and p hat to estimate. So we are estimating mu or p, which is the true mean or proportion. Written out in context. Falls between whatever our lower number and our upper number are. Why did I write units with a question mark? And so if I'm dealing with these two, which one's going to have units? And is P going to have units? No, so that's why I put the question mark. Mean would have units, or should typically have units, but proportion's never going to. So this is the part that people get confused with is me saying we are blank percent confident. This part right here is essentially saying, side note, asterisk, reference what confidence level means. And that's kind of the way you think about it, because I'm not saying that my one lower upper that I just made is 95% sure to be the right thing. It's that applying the idea of confidence level, if I'm the one that I made, if I made a bunch of them, the ones that I made would fall in that many times. Did you say critical value?